So this is exercise related to topic atomic structure and the periodic table. In the first question, this question is about atom, ions and isotopes. So define the term nucleon number. How we define the term nucleon number? It is number of protons and neutrons inside the nucleus of atom. So that is known as the nucleon number. Then give the electronic structure of the following atoms and ions for sodium. So we want to write the electronic structure for sodium. So when we check sodium, the periodic table for Na, it is written 11 and 23. So 11 protons are there because it's an atom. So it will have equal number of proton and electrons. So if it is having 11 protons, it will have 11 electrons because overall it is neutral. So how we'll write the electronic structure or give the electronic structure? So arrangement of 11 electrons. The first shell it will have 2 electrons. The second shell it will have 8 electrons and the last shell it will have 1. So 2, 8 and 1, that total will make 11 electrons. What about phosphorus? Because the phosphorus it's 3 minus. When you check the phosphorus in the periodic table, it is 15 and 31. So in a phosphorus atom, there are 15 protons and there are 15 electrons. But because this phosphorus is having a charge of 3 minus or minus 3, it means it is having 3 extra electrons. So if it is having 15 protons, it is having 18 electrons. So we have to arrange 18 electrons here. So it will be 2, 8 and 8. Is it clear? The electronic structure of sodium and phosphorus ion, sodium atom and phosphorus ion. Then give one medical use of radioactive isotopes where we use these radioactive isotopes. So we use for treatment of cancer, or we can also say radiotherapy. So treatment of cancer or radiotherapy having a same meaning. What is meant by the term relative atomic mass? So these are certain definitions which you have to learn or memorize. So how we define the term relative atomic mass? So it is average mass of an atom which is compared with carbon 12. So the standard definition, it is average mass of atom compared with carbon 12 atom. We call that as relative atomic mass. Suggests why the relative atomic mass of a chlorine is not the whole number. So what could be a reason why when you check a periodic table you will find for chlorine it is written 17 and 35.5, or it can be written like this. So 17 at the top and 35.5 at the bottom. So why this mass here is not the whole number, why it is in decimal? So reason for that, because chlorine is having isotopes. Isotopes means they have different masses and these isotopes are not in the same proportion. So why the atomic mass or of an element can be in decimal? Because chlorine contain isotopes that is why the atomic mass of the chlorine is not a whole number. Otherwise, for example, if it was not having isotope, then it should be a, or if it was not having an isotope, common isotope, then it will be a whole number. Like example, if I say for hydrogen, we used to write 1 and 1. So why there's a whole number here? Because there are isotopes of the hydrogen, but that's not very common. But in case of chlorine, what we have the two isotopes of the chlorine. One of the isotope of a chlorine is 17 and 35, and the other isotope of the chlorine is 17 and 37. And they are not in equal percentage. This isotope of chlorine is 75%, and this isotope of a chlorine is 25%. So when we take the average mass of these two isotopes with respect to their percentage, that average mass will come out as 35.5. Is it clear? This part E, the question why the relative atomic mass of the chlorine is not a whole number. So when the isotopes are there, common isotopes are there, it will not be a whole number. Look, for example, when you have oxygen, we used to write 8 and 16. But for chlorine, we are writing 17 and 35.5. So the question is, why for chlorine it is not the whole number here, whole number like 35, 36, 37, but here in example of oxygen it is a whole number. So what could be a reason for that? Because here in case of oxygen, when we are taking the mass, we are not considering the isotope of the oxygen. So here there is no isotope. But in this example, when we are getting the mass in decimal, so what does it mean? It means we are considering the isotopes and we are taking the average mass of these isotope. So when we are considering the isotope, the mass will not be in a whole number. When we are not considering the isotope, the mass will be in whole number. Is it clear? So when you check the periodic table, some of the masses are given in whole number and some of the masses are not in whole number. So what does it mean? Why some of the masses are in whole number and some of the masses are not in whole number is due to the presence of the isotopes. So if we are considering the isotope, the mass will be in decimal. If we are not considering the isotope, the mass will be in whole number. So example here, when you check these masses here, for helium it is written 4, hydrogen it is written 1, lithium 7, beryllium 9, boron 11, carbon 12, nitrogen 14, oxygen 16, fluorine 19, neon 20, sodium 23, all are whole numbers here. But when you come to chlorine, you find it is written 35.5. So why for chlorine it is written 35.5, but for rest others it is written whole numbers? Because for chlorine, when we are taking the mass, we are considering the isotopes of, so we consider the isotopes, and when we consider the isotope, we are taking the average mass of the isotope. That's why the mass of the chlorine is in decimal, where mass of other elements are written in whole number. Is it clear? So this is the average mass of the two isotopes of chlorine. Is it clear? That's part E. That why the whole, it's not a whole number, because in chlorine we are considering the isotopes and taking the average mass of isotopes. That is why the final mass is not a whole number. The difference between the ions and isotope, ions, they have different number of proton and electron, and isotope have different masses. Like example, if I say we have chlorine ion, so if I say I have a chloride ion, so what does it mean? It means it has different number of proton and electron. Like this is having 17 protons and it is having 18 electron. That is ion. But what is the meaning of isotope? The term isotope means they have different masses. Like in case of chlorine, one of the isotope is 35, another one is 37. So when they have different masses, we call them as isotopes. And isotopes have same proton but different neutrons. In question 2, we have to complete the table. Proton is having a charge of +1 and relative mass is 1. Neutron does not have any charge and relative mass 1. Electron, relative charge is -1 and relative mass is 1 divided by 1840. So the lightest one is electron, and proton and neutron have the same masses. The following are the isotopes of carbon. So three isotopes of carbon are given: 12 and 6, 13, 6 and 14, 6. In terms of number of proton, neutron and electron, how these three isotopes are same and how they are different. So how these isotopes are same? They have same number of protons and electrons. And how they are different from each other? They have different number of neutrons. So as you can see, when we find all of them have are atoms, so this contains 6 proton, this also contains 6 proton, this contains 6 proton. Because all of them are atoms, so they should have same number of electrons as well, so 6 electrons. And what about the neutron? When we subtract 12 minus 6, so neutron will be 6, 13 minus 6, so neutron will be 7, and 14 minus 6, so neutron will be 8. The neutron number is the difference between the atomic mass and atomic number. Like it is written 12 and 6. So when you subtract the two number, the number of neutron will be 12 minus 6. So the first one, the number of neutron is 6. For the second one, which is 13 and 6, the number of neutron will be 13 minus 6, which is equals to 7. And the third one, which is 14 and 8, the number of neutron 14 minus 6, that is equals to 14 and 6, so 14 minus 6, that's equal to 8. So they all have same number of protons, same number of electron, but different number of neutrons. Why do all isotopes have the same chemical properties? So what is the reason why isotopes have the same chemical properties? What about the electronic structure? They all have the same electronic structure. What is the electronic structure of Because they have same number of electrons, so they all have same electronic structure. Electronic structure of the first isotope will be 2 4, second one will also be 2 4, and third one will also be 2 and 4. So because they have same number of electron in the outermost shell, so when they have the same number of electron in the last shell, they will have the same chemical properties, because the chemical properties depends on the number of electrons present in the last shell. Yeah, because it's an atom, when something is an atom, it will have equal number of protons and electrons. Is it clear, this question? That what is same for isotopes? Isotopes will have same number of proton and electron, and they will have different number of neutron. And why do isotopes have the same chemical properties? Because they have same number of electron in the last shell, because each isotope here of carbon here will have 4 electron in the outermost shell. In question 3, the table gives information about 5 particles A, B, C, D and E. Answer the following using information. Each particle may be used once, more than once, or not at all. Which particle is an atom with atomic number 12? Atomic number means the number of the proton. So which atom is having 12 protons? So B is having 12 protons, that's why B is the right answer for this one. The second, in which atom nucleon number? Nucleon number means the sum of neutron and proton. When we add neutron and proton, what we call that as nucleon. So when we add neutron and proton, we should get 14. So when we add 6 plus 8, that will be A, makes 14. Which ion with a positive charge? To be a positive charge, it should have more proton and less electrons. So which of them is having more proton? So more protons and less electrons. So when you check, this is having 13 proton and 10 electrons. So this should be a positive charge. Which has only one electron in the outer shell? So how to work out number of electron in the outer shell? So you have to write the electronic configuration for each. So to identify the number of electron in the outermost shell, I have to write the electronic configuration of each. So here, if I write the electronic structure, it will be 2 4. When I write the electronic structure, it will be 2 8 and 2. This will be 2 8 2 8, and this will be 2 8 and 1. So this is having one electron in the outermost shell, so that's why E is the right answer. D is an ion of an element. Identify the element and write the formula. So D is an ion. So how to identify the element? So we have to check a periodic table. A periodic table element with proton number 8. So when you check the periodic table, the element with proton number 8, that is oxygen. So basically this D is oxygen. So this one is oxygen. It is having 8 protons. And what is the nucleon number? 8 plus 8, 16. But there should be a charge as well. It is having 8 proton and 10 electrons. So electrons are extra. So the charge will be -2 or 2 minus. Is it clear? Discussion. So using a proton number, we identify the element that this must be oxygen. And then atomic number of proton number is 8. Atomic mass, the sum of proton and neutron. 8 plus 8, that's make 16. In the question, they asked D is an ion of an element. So D is an ion of an element. Identify the element. How to identify the element? You identify the element from proton. D is having 8 protons. So using a periodic table, you will find an element with 8 protons. So which element is having 8 proton? You will find oxygen is having 8 proton. So actually this D is oxygen. So first you will write that this D is oxygen. So you will write the symbol for oxygen. Then there are proton. Because it is having 8 protons, so you can write proton number. Then the nucleon number is a sum of neutron and proton. So 8 plus 8, that's 16. And what about the charge? Because there are 8 protons and 10 electrons, and electrons are more, so it means it should be a negative charge. And what should be the charge? Because 2 extra electrons are there, so the charge should be 2 minus or minus 2. In the exam, the periodic table will be there, so you can use the periodic table to answer these type of questions. Complete the table to show the electronic structure of atoms and ions. For fluorine atom, first one is done. For silicon, again you have to use a periodic table. Silicon, you will check the periodic table. The position of a silicon is here. So it is silicon atom. So silicon atom is having 14 protons. So how many electrons should be there? It should have 14 electrons as well. Because it's an atom in the question. So silicon is having 14 protons as well as 14 electrons, because in the question it is an atom, no charge. So we have to arrange 14 electrons. How we arrange 14 electrons? The first shell will have 2, the second shell will have 8, that make total 10, and the last shell will have 4 electrons, so the total will be 14. The third one is calcium. When you check the periodic table, calcium, it is written 20 and 40. So calcium is having 20 protons. But in the question, it's not a calcium atom, it is a calcium ion. A charge of 2 plus or plus 2. So if it is having 20 protons, how many electrons will be there in this calcium? If calcium is having 20 protons, what is it? And having a charge, the calcium ion is having a charge of 2 plus or plus 2. So how many electrons will be there? So it will have 18 electrons, because the charge is positive, so electrons should be less than protons. So we have 18 electrons. So basically it is having 20 protons and it is having 18 electrons. So we have to arrange 18 electrons. How we arrange? It will be 2, 8 and 8. Same thing for nitrogen, which is 7 and 14. So it is having 7 protons. But in the question it is minus 3. So it means it is having 3 extra electrons. So if there are 7 protons, then it means it should have 10 electron, because it's an ion. Ion should have different number of proton and electron. If it's a positive ion, it will have more protons, and if it's a negative ion, it will have less electrons. So the electronic configuration, basically we have 7 protons and we have 10 electrons. So we have to arrange 10 electrons. How we arrange 10 electron? It will be 2 and 8. Then the last part, predict the formula of a compound between calcium and nitrogen. So calcium valency is given 2 plus, nitrogen is minus 3. First we simplify. It is already simplified, so we cross multiply. It will be Ca3 and 2. Is it clear? Discussion 4. Part B, predict the formula of a compound. How to predict the formula of a compound or how to write a formula? You have calcium, it is written 2 plus, and you have nitrogen, it is written minus 3. How we write a chemical formula? We simplify the valency. It is already simplified and 2 and 3 are already simplified. You cannot further simplify. And then what you do, you cross multiply. So when you cross multiply, it will be Ca3 and 2. So the formula is Ca3 and 2 for calcium nitride. That's how we write a formula of ionic compounds. Then substance can be classified as element, compound, or a mixture. Which of state whether each of the following is element, compound, or a mixture. We are not considering the sign. We just consider the number. If you remember how to write a chemical formula, so it's written plus 2 here and it is written 3 minus or minus 3. We do not consider the sign, we only consider the number when we are writing a chemical formula. This exercise we discussed earlier. So we do not consider the positive or negative sign, we simplify the valency and we just cross multiply the number. So we don't bother about positive or negative sign. In question 5, substance can be classified as element, compounds, or mixture. State whether each of the following is element. So brass is a mixture alloy. Gold is an element you will find in a periodic table. Butane, you will learn in organic chemistry. Butane is actually a mixture of chemical combination of carbon and hydrogen. So when chemically substance combine, we call that as compound. And air is a mixture of different gases, oxygen, nitrogen, carbon dioxide, and inert gases. In question 6, define the term molecule. So how we define the term molecule? Group of atoms, and or when two or more atoms are together, we call that as molecule. Define the term element. So how we define the term element? A substance that cannot be broken down chemically, or the substance consists of identical atoms. Or chemically it cannot be broken down, so we call that substance as element. In part B, the table shows a composition of 4 atoms or ions A, B, C, D. What is the atomic number of A? What is the atomic number of A? Atomic number means the proton number. So when we check the proton number of A, it will come out as 10. What is the nucleon number of B? Nucleon number means the sum of neutron and proton. So when you add neutron and proton for B, so 10 plus 12, that will make 22. Which of A, B, C, D are isotopes of each other? To be an isotope, they should have same number of proton and they should have different number of neutron. So when you check A and B have same number of proton and different number of neutrons. So A and B. Which of them are atoms? Atoms means they will have same number of proton and electron. So here 10 proton, 10 electrons. So A is an atom. 10 proton, 10. B is also an atom. 12 protons, 10 and 13 and 10. So it means it's not an atom, it is an ion. And which of them are positive ion? To be a positive ion, they should have more protons than electrons. So C is having more proton, D is also having more protons. So C and D. Then the last part, there's another question after that. Complete the table, the number of the proton when we check for sodium. So what you have to do, you have to check the periodic table. When you check sodium, it's having 11 protons. And because it's an atom, so it should have equal number of electrons. But when you check sulfur, it's -2 or 2 minus. So sulfur is having 16 protons. So sulfur is having 16 proton, and how many electron will be there? Because the charge is 2 minus, so it should have extra electrons, so 18 electrons. Then Cl2. So Cl2 means 2 chlorine atoms together. Each chlorine, when we check the periodic table, one chlorine is having 17 proton. But in the question, they're not asking for chlorine, they're asking for chlorine molecule, Cl2. So if one chlorine is having 17 protons, the other chlorine will also have 17. So the total number of protons, 17 plus 17, that make 34. And because there is no charge here, it's a neutral, so it will have equal number of electrons. Is it clear, this table? Part C, why the chlorine molecule is having 34 protons? Because one chlorine in a periodic table, they give the structure of one chlorine that's having 17 proton. So the other chlorine will also have 17 protons. So total number of protons in a chlorine molecule or Cl2 will be 34. And there's no charge written on this, so it will have equal number of electrons as well. In question 7, the table gives information about 4 different particles. Complete the table. The first row has been done for you. There is no charge on this particle, so if there is no charge, if it's having 11 protons, then it should have 11 electrons. Again, and this one also, it does not have any charge. So if it is having 18 electrons, then it should have 18 protons. But what about the next one? It's having 18 electron and 17 proton. Electronic structure, arrangement of 18 electron. So it will, first shell it will be 2, second shell it will be 8, and the third shell it will also be 8. And what about the charge? Here we have 18 and 17, so more electron, less proton, so the charge will be -1. Because electrons are negative, if electrons are more, then it will be a negatively charged. One extra electron is there, that's why it is -1. If two extra electrons, it will be -2. Then give two particles from a table which are isotopes. So A and B have the same number of proton but different number of neutron. So A and B are the isotopes. The element Z is in the same group of a periodic table as A. So Z and A are in the same group of periodic table. Identify Z. We will leave this part. Why? Because it is related to chapter 9. So we will not answer right now. It is related to periodic table, which is chapter 9. In part D, C is unreactive. If it is unreactive, Use information, explain why. So explain why C is unreactive. When the element is having a complete shell, it is unreactive. So you will mention it has complete last shell. That is why it is unreactive, or it does not react. So whenever the last shell is complete, how we know that these elements are isotopes? The definition of isotope, Abdullah, is state to be an isotope, they should have same number of proton and different number of neutron. So when you check, A and B have the same number of protons and they have different number of neutron. So when elements have same number of protons and different number of neutron, we call them as isotopes. So two particles which are isotope, that is A and B. Part C is not there. You don't have to answer part C. And part D, which is why C is unreactive, because it is having a complete last shell. Whenever element is having a complete last shell, it will be unreactive. Is it clear? Question 7. 2 minutes left, so I'll complete quickly this. Calcium, magnesium, calcium, strontium are group 2. Complete the table for calcium. So calcium is having 20 electrons. So first shell it will have 2, second shell 8, third shell 8, and the last shell 2. Describe how the arrangement of electron in strontium atom is similar. If the element belongs to same group, so they will have the same number of electron in the outermost shell. So how they are similar? Strontium will have same number of electron in the last shell, because all belongs to group 2, so all will have 2 electron in the last shell. And how they are different? Because the number of shells will be different. In magnesium will have different shells, as you can see the periodic table here. Magnesium, calcium and strontium, they belongs to group 2. How they are similar? So they all will have 2 electron in the last shell. And how they are different from each other? They will have different number of shells. Is it clear? The last question. How atoms in the same group are similar? They will have same number of electron in the last shell. And how they are different from each other? They will have different number of shell. So whenever you're checking a periodic table, it will always be like this, that elements in the same group will have same number of electron in the last shell and they will have different number of shells in the structure. So this was a weekly homework exercise related to atomic structure and periodic table.